Hello 3D printing friends. Today on the BV3D channel, we'll design and print a way to store this delightful jumble of rectangular prisms. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. So there's a small problem here at the BV3D channel, and that is what to do with 48 small wooden blocks which are the elements of a non-name brand Jenga style game. These 48 blocks do not have a home. Well, they live in a cabinet where other games are stored, but they don't have their own little box. So even if they get stacked neatly in the cabinet, inevitably they'll get bumped while removing another game, and then we have to play the much less fun game of pick up that thing you knocked over before you can play that game you wanted to play. So how can we solve this? Well, one way is to just get a small cardboard box and dump the pile of blocks into it, but that isn't very attractive, and then you have to dump the box out and carefully stack the blocks before you can get to playing. But a better way is to have a box that's just the right size for the completed stack, so that when game time rolls around, you can invert the box and simply lift it up off the stack, and hey, what do you know? You're ready to play not Jenga. And when you have a 3D printer available and free online modeling software such as Tinkercad, you can have a nice solution ready to go faster than you can say disestablishmentarianism about 1,800 times in a row. That's a little over 2 hours. So let's design and print a box. The first thing to find out is, how big should the box be? Well, that's going to involve measuring the blocks in their ready-to-play configuration. So close enough. So here we go. Each block is about 48 millimeters wide, so that means the base of the tower is 48 millimeters by 48 millimeters. And by tipping the stack on its side, I can see that its height is 158 millimeters. Whatever we design, we'll need to have at least that much space carved out of it for this stack of can't legally call it Jenga blocks to fit inside. But I want the stack to fit easily, so it can come back out again. So I'm going to add 2 millimeters to each dimension to get a little bit of breathing room. So that means a space of 50 millimeters by 50 millimeters and 160 millimeters tall. Armed with that information, let's get into Tinkercad. Some of you may be familiar with Tinkercad, but for those who aren't, it's a free online 3D modeling app that runs right in your web browser. There's nothing to download. Just go to tinkercad.com, create an account, and start playing. It differs from other 3D modeling applications such as Fusion 360 in its approach to design. In Fusion, you start by drawing two-dimensional shapes and then pulling them up into the third dimension. In Tinkercad, you start with three-dimensional primitives such as cubes and cylinders, and by grouping them together, you can create more complex geometries. These can also be solid objects or whole objects, and by whole, I mean that in the same sense as I need another 3D printer like I need a hole in my head. Maybe a hole would look okay here? Solid objects are, as you might have guessed, solid, completely filled things. Whole objects are generally used as cutting tools. Grouping a hole with a solid removes the hole's shape from the solid. So since I know that I want to cut a shape that's 50 millimeters by 50 millimeters by 160 millimeters tall out of something, one way to design this block box would be to drag out a hole-type box object from the basic shapes list and out onto the work plane, and then set its measurements to that size. And that results in a nice cutting tool. Then I could drag out a solid box and set its measurements to a little bit larger than that. In this case, I'll add another 2 millimeters to it, so I'll have a solid box that's 52 millimeters by 52 millimeters by 162 millimeters tall. Selecting both objects and using the alignment tool to center them on the X and Y axes and align them at their tops puts the cutting tool into the necessary position. Grouping the two objects together completes the cut, and I have a tall box with enough space inside to put these blocks. But honestly, this thing is going to take a long time to print. There are going to be inner walls and outer walls and probably some infill, And all that takes time. You'll end up with a strong print, of course, but still, it would probably be far stronger than it needed to be and use more plastic than it needed to use to do the job that it needs to do. So this box, I think, is a job for vase mode. Depending on the slicer that you use, this is called vase mode, spiralized vase mode, or spiralized outer contour, and the kind of model geometry that this mode of printing works with is completely solid objects with no voids. Essentially what it does is print only the outer wall of the model, and it prints it in a continuous spiral from the bottom to the top. Except for the very bottom, that prints normally with however many bottom layers your slicer is set to print, and there are no top layers, but the rest of it, all the way up, is a spiral, kind of like a slinky. I've used this analogy before when talking about vase mode in the video where I designed that desktop trash can. Wow, that feels like it was a really long time ago. Anyway, this method of printing, it's useful. It's only printing one outer wall, and it's slowly moving up the z-axis as the nozzle goes around. By the time the nozzle completes one orbit around the model, the z-axis has moved up by one layer. It's not having to stop extruding, bump up to the next layer, and start extruding again, which can leave a mark on the model, so there's not going to be a z-seam running up the side of the thing when it gets printed. Well, okay, let's get back to the model because I want to redo this for vase mode instead of regular printing. So let's do this. I'm going to ungroup these boxes, and then I'm going to delete the whole part, leaving just the solid part. Something else I want to do is add some text to the side of the box. So I'll grab the text object and drag it out onto the work plane. I probably shouldn't do this, but I'm going to change the text to Jenga. And now that I've got some text, I could rotate it so that it's vertical, and I could put it on the side of the tower so that it was sticking out a little bit, and I could group those two objects together. And it would look like this. But that won't print well, and here's why. The text is sticking out at a 90-degree angle from the side of the box. Now usually the best I can hope for is being able to get a 45-degree angle on something that prints in vase mode, and this is because vase mode only has that one single wall or perimeter. So for vertical things, vase mode works great. As each new perimeter is printed, it stacks up nicely right on top of the one below. When the model's features start branching out 45 degrees from vertical, there's not as much material underneath for the filament to grab onto, but there's enough that the print can still finish successfully. But when the model's features have a larger angle away from vertical, look what happens. In this example, the perimeters are printing along happily, but then the model angles out at 60 degrees from vertical. Now, there's nothing for the filament to grab onto, and the result is sadness and failure. Now, these examples show a 2-to-1 ratio between layer width and layer height, and this is a very common ratio. Think printing 0.4 millimeter wide layers with a layer height of 0.2 millimeters. So the ability to print larger angles is affected by this ratio. The odds of success can be improved by printing with wider layers, shorter layers, or both. But let's get back to the text. How can we fix this issue of having a 90-degree sadness and failure angle with the text sticking out? Can we somehow push the text in instead? Well, no, because the angle is still going to be 90 degrees. Well, okay, then what can we do? Well, the answer is beveling. No, that's not short for bed leveling, and anyway, bed leveling doesn't fix every single 3D printing issue ever. A bevel is a slope from the horizontal or vertical. And right here in Tinkercad, when we're working with the text object, there's a slider that does precisely that. There are little adjustments that you can make with the sliders or by typing in values directly. I'll set it like this with one segment and the bevel right about there. There, that looks good. Now I can position the text with the tower so that the beveled edges of the text are all that sticks out. Then I can group the text and the tower together and export that out to an STL file. So I'll add this STL into Prusa Slicer. I'm going to modify the print settings just a bit to turn on Vase mode, and I want to print this with a thicker perimeter than normal. So over in the Advanced Settings in the Print Settings tab, I'll adjust the extrusion width. Now, not everyone knows you can do this, but you can actually specify a wider extrusion than your nozzle's diameter, at least up to a certain point. The printer will extrude extra filament to make that happen. In this case, I'm going to set the extrusion width to 0.8 millimeters for all of the different extrusion widths. You won't get as good of results as you would with a real 0.8 millimeter nozzle, but for vases it tends to work okay. If you try this and you don't get good results, try dialing the extrusion width back to about 0.6 millimeters. Then in the layers and perimeter settings, I'm going to check the box to enable Vase mode printing. Now when I do that, Prusa Slicer offers to adjust several other settings to bring them in line with what's necessary for a Vase mode print. So I'll click yes to make those changes. Now I'll slice that file. Prusa Slicer says it's going to take just a little over 2 hours to print this out, and I will tell you that although I don't know what sort of dark magic it uses, Prusa Slicer is spooky accurate when it comes to printing time estimates. Okay, so all that's left to do is export the file to G-code and print it out. For this project, I'll be using my old Prusa Mark III and printing with some silver/gray eSun PLA Plus filament. I've copied the G-code file to the Mark III's card, so I'll pop that card in the printer, pick the file, and come back in a couple of hours to see if this thing actually fits the block tower. Okay, the print is done, and it came out pretty okay. I mean, I did print it in draft mode, so I'm not expecting superb, pristine quality from the print. I was more focused on getting the print done quickly. It is, after all, intended to be a functional print rather than a decorative one. So with that in mind, it came out okay, and the beveling on the letters did what I expected. But before I can call this a success, I need to find out if it's going to do the job of containing the block tower. Yes, it fits. Awesome. When it's time to play the game, we can just turn the box upside down and lift it off the blocks. And hey, what do you know? It's ready to go. And when we're done playing, we'll stack the tower again and we'll slide the box down on top of it and then put it away. And that way it'll be ready to go next time it's game time. Now, I might want to make a little lid for it later, and that'll literally just be a short, solid box, maybe 2 millimeters wider than the tower, and that'll probably only take 15 minutes to print. But I'm pretty happy with how this turned out. You might even say I can barely contain my excitement. So let's see, we covered what Vase mode is, and we covered why Vase mode doesn't do well with overhangs more than about 45 degrees. Oh, and we went over setting extrusion width to a value wider than your printer's nozzle diameter. Now, when I was first starting out in 3D printing, that's a thing I didn't know you could do, but you can, and it's a simple way to get thicker walls on prints without having to swap a nozzle. I think it's neat that with 3D printing, you can identify a need for a very specific size of container around the house, and then you can sit down and in a few minutes design that very specific size of container, and then a couple of hours later, you can actually be holding that container in your hand and making use of it. For a lot of people, that's the stuff of the future. For those of us with 3D printers, we get to live that future a little sooner. Well, 3D printing friends, that's about all the time we have for this episode, and now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. Check these other videos here to my left, and hey, please consider subscribing. It's absolutely free, and it helps motivate me to keep making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.